Hi, in the previous video, we introduced floor in BST problem. We talked about naive solution, then efficient solution. The efficient solution is similar to BST search. We begin with the root. If we find that root key is same as the key that we are searching, we return it. If root key is greater, then we go to the left side because the root and its right side cannot be the floor. And if root key is smaller, then root itself can be a potential floor. So we assign result as root and then we go to the right side. That's the simple idea, and this is the simple implementation of the simple idea. It's an iterative implementation, so it does not require extra space. It's a big O of 1 extra space solution. Let's do a dry run of this solution for this example with a key to be searched as 58. So we begin with the root, right? We see that 58 is greater than 50, right? So which case we come in? We have initialized the result as null. Our root is currently this node, and this we do not go into this case. We do not go into this case. We come here because root is smaller. And what we do in this case? We first initialize the result as reference to this 50, right? Now what we do? We make root equal to root.right. So we come here. Now this is our new root. And we again begin from here and we check if it is equal, greater or smaller. Now which case we are in? It is greater, right? So we go to the left side. We update the root here and we go to the left side. Now we again check whether it is equal, greater or smaller. It is greater, so we again go to the left side. So root comes here. Now we again check whether it is equal, greater or smaller. It's smaller this time. So we update our result as reference of this node 55. And since it is smaller, we need to go to the right side also. So our root now becomes root.right, which is null. So root now becomes null. And when root becomes null, we stop. We come out of the loop and we return the result. So we get our output as reference of 50. Let us do one more dry run for this value 35. We begin with the root. We see that root is greater, so we go to the left side, right? We make this as root. We see that root is smaller, so we update our result as this 30 and we go to the right side. We see that root is greater, so we go to the left side. And now root becomes null, so we stop. So what was our result? Our result was 30 and we return reference of this node 30. What is the time complexity of this solution? This is like searching in a BST. We are beginning with a root and we are going across the height, which is big O of h. And since it is an iterative solution, it requires big O of 1 extra space.